All right, so here's 4-4. I'll collect 4-3 at the end of class, okay? We got to get going on this.
Thank you.
It's Wednesday. I got to remember what time we get out of here. 2:15. All right. So here we go. Got a triangle. Actually, I don't want that triangle. Grab the wrong triangle. Let me find a different triangle. Yeah, good luck. Okay, here we go. Here's a triangle. You should be taking notes. Shouldn't be any talking. Everybody should be paying attention and watching. I'm going to copy and paste it. So if I copy and paste it, what do you think is true about these? They're congruent. They're congruent to each other. All right. So let's just make this ABC. Make it super easy. And DE. Let's call it XYZ. Just be different. Okay. You know I copied and pasted it, right? And so they must be congruent if I copied and pasted on a computer program. But if all you did was just see these two triangles on a piece of paper in front of you, could you say that they are congruent to each other? You cannot. You cannot say they're congruent to each other. You have to be told certain information, okay? We talked about 2 days ago, I said if I could show you that all three angles of that triangle equal all three angles of this one, and all three sides of that equal to the corresponding sides over here, then they're congruent to each other. Then yesterday we said, okay, that's 6 things you had to show. But yesterday we said you don't have to show all 6 things. We can only show what? 3 things, correct? What was the first one we said yesterday? I think that was the second one. What was the first one we did? Yeah, so for instance, if I said that this side was equal to this side, this angle was equal to this angle, and this side was equal to this side, that's enough to say that those triangles are congruent. So now, if this is on a piece of paper, on a quiz or a test, and they gave you this amount of information right there, can you say that these triangles are congruent to each other? Yes, you can. Okay, give me the reason why. What would the reason be that the triangles are congruent to each other, John? No, give me 3 things. No, give me, boom, boom, boom. 3 letters. Thank you. Side, angle, side. Okay? We say it in words, but we write it down in letters. Okay? So side, angle, side. So if I asked you why, give me a reason why these triangles are congruent, you would say what? Side, angle, side. That was yesterday. Okay? Let's get rid of that stuff. Here's another thing we did yesterday. Then we're going to add on to it today. They could say that this angle is equal to this angle. This one right here is equal to this one right here. And then the side in between them. Oh, that's one thing I didn't say on the last one. What had to be true about that angle and those sides? That angle had to be between the 2 sides. Okay? It was called the included angle. Do you remember that from yesterday? Okay, watch the video. It'll be on there.
Would you happen to have an extra group book?
So this one right here. So we did side, angle, side. So this one right here, look at the side. It's in between those 2 angles. So we can now say these triangles are congruent to each other for what reason? Angle, side, angle. Very good. Okay, angle, side, angle. Now we write it down ASA, but we say, if I ask you verbally, we would say angle, side, angle. And that would be your reason why these triangles are congruent to each other. Another thing that I'm going to ask you on the quiz that I didn't mention today that you had to do in your homework was write a congruency statement. Okay, well, this is an easy one, but what's the congruency statement for this triangle and this triangle? What would I write? I would say triangle what? What would I call this triangle right here? ABC, all right? You could call it any of those 3 letters. It doesn't matter what order you put them in. But it does matter, depending on what you call the first one, the second triangle definitely matters what order you put it in, okay? So if I call this ABC, then I'm going to call this one what? XYZ. X, Y, Z. This was really easy because both of those triangles are facing the same way. They're not twisted, they're not flipped or anything like that. So that was pretty easy. But how do I know for sure that the A and the X go together? Well, because they both have one arc on it, okay? And what about the C? How do I know the C and the Z are in the same spot? Because they both have the two arcs. And what about the B and the Y? Well, that has no arc, okay? So that's the only one that doesn't have an arc. And so they would be equal to each other as well. So if I call this ABC, I have to call this XYZ, or I'm marking it wrong, okay? So this part right here is called the congruency statement. Did you write that down anywhere on your notes? Because on the quiz, I'm going to give you, and I think we're taking a quiz this week, aren't we?
No, it's next week.
Is it next?
You said it's like next Tuesday.
Okay. Okay, it was my other class. I said we're taking a quiz on Friday. You're right, we don't. Yep, the quiz is on Tuesday. All right, so the quiz on Tuesday is going to ask you for a congruency statement, which is this thing right here, okay? And then it's going to ask you for a reason why the triangles are congruent, and that's this right here, okay? So far, we only have two reasons. We have side, we have angle, side, angle. Today, we're going to learn one more, and then the next day, we're going to learn another one, okay? And then the next day, we're going to learn some with right triangles, okay? So we're not finished with this, but that's what we got so far. We got two so far, and then what we're going to do today, all right? There was a question. I saw a hand up. Who had a question? Okay. All right. Everybody with me on that? That's review, okay? Yesterday's YouTube video is up online. I made a big deal yesterday about, I said, I always, after I teach this, the next class, I always go and put it up on YouTube. And yesterday, guess what I forgot to do? I forgot to put it on YouTube. It's on there now. I did it this morning, and so it is on there now. So I know you must have been disappointed when you looked last night and it wasn't on there.
I was disappointed.
Sure you were. I bet you nobody even looked for it. Question. All right, we have a question. Hey, we have a legitimate question here for once, okay? So let's listen. Okay. Yes. Did I put the congruent statement on there? Oh, I didn't put the congruent. Yeah, I need to put the. Guys, listen up. So I might have forgotten to put the congruency thing on there, but you need to put equal sign congruent. Yeah, I think I forgot to put the congruency. That needs to be in there as well. So you need to have triangle ABC, and then the congruent symbol, and then triangle XYZ. Now, what if I would have called this, I don't want to take too long on this because I talked a lot about this yesterday, but what if I called this triangle, let's say BAC? If I call this BAC, what would I call this one over here? Dominic? Did you have a question? Okay. Yes, go. So if I call this BAC, I would have to call this YXZ. Okay, YXZ. All right, everybody follow me? So what I do when I grade the quiz and I grade the test, you could call this triangle a bunch of different things. I think there's 6 different arrangements that you could make to call this thing. I believe there are. So what I have to do is I got to look to see what you called this one and make sure that those letters match up with this one. All right. So you could call the first one whatever you wanted. All right. But again, the B and the Y have to match up. The A and the X have to match up. The C and the Z have to match up. Everybody got it on that? Okay. So, and those answers that you probably were looking at earlier, when I put the answers up on the screen, you got to understand that they might say XYZ, but you put ZYX, but you still might have gotten it right, okay, because you may have called the first triangle something different than they did. Does that make any sense? All right, so you have to be able to understand if you're getting them right. Okay, so that's 2. They were congruence postulates. Now this lesson 4.4 says we're going to apply these congruent postulates. We're going to talk about why it says applying them in a second, all right? But I'm going to show you another one. This one is not a postulate. This one is actually a theorem. And what can you do with theorems that you can't do with postulates? What do you do with theorems? You can do what to them? You can prove them, okay? You can prove a theorem but you can't prove a postulate. A postulate is just a fact that's just accepted as fact. Okay, everybody understand that? My phone is going off. People want my blood. Literally. It's the blood bank. Let me see. Hold up. All right, so here we go. So now here's another congruence, but it's not a postulate. This is called a congruence theorem. And here it is. I'll just show it to you. So if they give you an angle equal to another angle on this triangle, all right, now watch. They give you another angle. That's not enough right now, okay? You can't just have two angles and say that they're congruent to each other. Because I could make this triangle the same shape, but I could make it smaller. The angles would still be equal to each other, but they wouldn't be congruent, all right? We already said angle, side, angle, so we've already dealt with that. But there's another one. It's called angle, angle, and guess what? Side. All right? Now, why is that different than angle, side, angle? So angle, side, oops, there goes my pen again, every day. Watch, what's the difference between angle, side, angle, and angle, angle, side? So what do we say about this side? This side was what? In between, right. What was the geometry word we used? Okay, included, right. They call it the included side, okay? This one is the side in between the two angles? No, it's not. If it was, it would just be angle, side, angle. So we don't call it the included side, we call it the non-included side, okay? No, we say non-included, okay? Yeah, right. It's just not in between these. It's still on the triangle, but it's not in between these. So we would call this the non-included side. So if I was to give you information, right, that this angle was equal to this one, A was equal to X, angle C was equal to angle Z, and then side BC was equal to YZ, that's enough to be able to say that they're congruent triangles. Okay, so we have three ways now to show that triangles are congruent. The first one was side, angle, side. Then it was angle, side, angle. And now today, it's what? Angle, angle, side. Angle, angle, side. Okay? Now let me show you why. Let me show you why it says applying congruence postulates. Do you remember we talked about this? Was it yesterday? I think it was pretty recent. I don't know. If these two angles are equal to these two angles, what must be true about B and Y? Because you're taking both away from what? Look, this angle and this angle add up to what? 180. This angle and this one up here do what? Add up to 180. If these two are exactly the same as these two, you're taking the same thing away from 180, aren't you? Okay, so I don't know. Let's just make something up. Let's say this was 30 and this was 50. Okay? Then what would this one be? That would be 30 because it's equal to that, and this would be 50. Now watch very carefully. If this is 50 and that's 30, what's angle B going to be? It's going to be 100. Okay? Now watch. These are the same thing, right? The 30 and the 50 are the same thing, and we're taking them away from 180 again, so guess what angle Y is going to be? 100. So if I have two angles of one triangle equaling two angles of another triangle, what must be true about that third angle? It's got to be equal to each other. That's right. And I just kind of showed you with numbers right here that this and this would be equal to each other. So I want you to see this. So that means angle B, I'll put 3 arcs here. Since that has 1, that has 2, this one has 3. And then this one is equal to each other. So watch very carefully. This is not necessarily something that you have to know for a homework or a quiz or a test or anything like that, but I just think it's kind of interesting. Remember, this angle-angle side thing is a theorem, okay? It's based on the postulates that we learned, okay? And that's why it says applying the postulate. So now, what's another way? Since I got all three angles equal to all three angles, I could also say that these two triangles are congruent because of, look, that, and that now. Do you see that? So what's another way that I could say those triangles are congruent? Angle what? Side angle. That's right. Okay. Since I know two of the angles are equal to each other, that must mean the third one has to be equal. Agreed? All right. So I could just say that the angles are now equal to each other, and now I could call this angle side angle. Angle side angle. So really, I don't really even need the angle side. That's why we say we're applying the postulate. Does that make any sense? Okay. Again, if you don't care about that, that's fine. You don't have to care about it, and you don't even have to know it for a quiz. Basketball? Okay. All right, watch the video tonight. We're going to do a few more things with this. All right, so there we go. Yeah. So that's our third congruence statement, okay? Let's do something else. We're not done. What? No. You came late. You stay here. John, go.
Okay, do I need to bring my book home?
Well, you got homework tonight, so you tell me.
No, whoa, what?
That's cheating. Whoa, Casey, I know you're not talking. You remember Spanish last year?
Does Jason play basketball? I know, but you never know. All right, let's do this one. Here we go. This postulate right here, this theorem, let's see what it is. It's a theorem. Now watch this. Everybody look. Everybody look. So here's a triangle. It's a special kind of triangle because this side is equal to this side. We give that a name. We have a special name for that. What is it? Isosceles. This is an isosceles triangle. When two sides are equal to each other, it's an isosceles triangle. So we have a theorem, and guess what it's called? It's an isosceles triangle, so what do you think the theorem's called? Isosceles triangle theorem. Okay, they don't make it that hard for you. So there's isosceles triangle theorem. I'll just shorten theorem, just THM. Is that all right? So this is called the isosceles triangle theorem, which says this. If you have two sides of a triangle that are equal to each other, thus you have a isosceles triangle. Okay? What it says is that the angles that are opposite, I got people talking, and I'm ready to give what this theorem says. If you have a triangle, two sides are equal, the theorem says this. I'm not going to write it out. It's in the book. You can write it in your notes if you want. It's right in the book. But what it says is if the two sides are equal, that the angles that are opposite those equal sides are also going to be equal to each other. So let's label it again, just so we can refer to these angles. So if these two sides are equal, the angles that are opposite those two sides are also equal to each other. So tell me what angles would be equal then? A and C, that's right. So if it was given that A, B, and BC are equal to each other, I can say, because of this theorem, that angle A is going to equal angle C. Okay? So for instance, if they said that was 5, and this was 5, and this was 40 degrees. Okay? That's all the information they told you. And they asked you to find the other two angles. Find angle B, find angle C. Okay, now you'd be able to do it. Before you wouldn't be able to do it, but you might be able to guess, but you wouldn't know for sure. So let's take a look at this. This side's equal to this side because they're both equal to 5, right? That means what? That means the angles that are opposite those two equal sides are equal to each other. So if this is 40 degrees, talk to me, then this has got to be 40 degrees. Everybody see that? That's because, if I ask you for a reason, the reason would be because of the isosceles triangle theorem. Now, you should be able to find angle B now, shouldn't you? That's 100 again. Okay, I just made super easy, numbers just to make it easy for you. So that's 100 degrees. It's not always going to be 100, but those last two just happen to be. All right, so if this is 40 and that's 40, that's 80. You take it away from 180 and you get 100. You see where we're going to use this? Okay, now let's get rid of all this red. What? Go. 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 Just go. All right. Here we go. You got the triangle. I'll call it ABC again. Everybody watch. This time they don't tell you the sides are equal. Guess what they're going to tell you this time? They're going to tell you two of the angles are equal. That's right. So they're going to tell you that angle A is equal to angle C. That's different from the other one. Because the other one, what did they tell you? They told you the sides were equal. And what could we figure out from that? We could figure out that the angles were then equal. Agreed? This time they tell you something completely different. They tell you this. Let's just make this 50 and 50. Is that all right? Just make it a little different. All right. So they tell you those angles are equal. What do you think then, or what do you think on this triangle that you could say about this triangle? What else could you say about this triangle? If the angles are equal to each other, then the sides are going to be equal. That's right. So it goes vice versa, right? So if the two sides are equal, that means that the two angles are equal. If they tell you that the two angles are equal, guess what that means? That the two sides are equal. Okay? So if they tell you that this is equal to this, then I could say that these two sides are equal. So what if they had a 7 right there? Then what could you tell about side BC? That's also 7 as well. Everybody with me on that? All right. It's as easy as that. It's pretty simple. All right. That's they call that the converse. Okay? Not like the sneakers, but it's the converse of the isosceles triangle theorem. Okay? So when they tell you the angles are equal, that means the sides are equal. That's the converse of the isosceles theorem. Okay? Because at first we didn't know that it was an isosceles triangle, did we? We just knew that the two angles were equal to each other. But then what can we say? If the two angles are equal to each other, that means the two sides are equal to each other. Therefore, it's what kind of a triangle? An isosceles triangle. Make sense? So that's not too hard. But it's going to come into play quite a bit. Let's see. We got one more thing to do. So let's see what kind of triangle. Yeah, let's do that. I don't know if I have one down here already. Yeah, I do. All right, so here's another triangle. Let's make it a little bit bigger so you can, oops, I don't want to do that. I want to hit the shift key. Does anybody know about like desktop publishing kind of stuff? If I hit the shift key and I grab that corner, what does that do? Does anybody know what that does to this? Watch. Here, I'm holding the shift key and oops. Let's try it again. Daggone it. Oh, you know what I did? I clicked something and I completely made this thing crooked. How in the world did I do that? I don't know. Well, let's just do this. Let's just do this. Let's make that look about like that. Okay, now watch. If I hit this, hit the shift key, what it does, it keeps it in proportion. Everybody see that? Okay, yeah, it's to scale. All right, so it doesn't make like one side bigger than the other or anything like that. So we have, I'll tell you what, let's do this. Let's start with the two angles. I'll show you why the thing is what it is, okay? If these two angles are equal to each other, all right, then I'll tell you what, let's just say this. Let's say all three angles are equal to each other. Now, you should be able to tell me, without me giving you any numbers whatsoever, you should be able to tell me how many degrees each of these angles are. How much? How much are each of the angles individually?
45, 45, 90.
They're all the same. They're all the same. 45, 45, 90 is not the same. 65? 60. Why 60? That's right. So 180 divided by 3, right? Because you got three angles. They're all exactly the same. We can divide 180 evenly by 3, correct? So what's 180 divided by 3? Is 60, all right? Because 18 divided by 3 is 6, and then the 0. So this has to be 60 degrees if all three angles are equal to each other. Doesn't matter how big the triangle is. If all three angles are exactly the same, that must mean they have to be 60 degrees. You with me? Now watch this. Now what do I know about the sides? Well, how could I say this? Let's just say I was told that two of these sides are equal to each other. How do I know if that side down here is equal to these two? Well, this is opposite of 60. This is opposite of 60. And then this is opposite of 60. So guess what? All three sides are going to be equal. So what we call this, let me just move this up just a little bit. What we say is this. When all the angles were equal to each other, what kind of a triangle did we call it? We've talked about this. This is not new. If all the angles were equal to each other, we call it an equiangular. Okay, we've talked about that. That's not new. We call that an equiangular what? Triangle. So an equiangular triangle, let's put a little arrow. An equiangular triangle is always going to be what? All three sides are equal, so an equal what? What do we talk about? Say it, I heard it. Lateral. Equilateral. Okay, triangle. So if it's equiangular, then it has to be what? Equilateral. What if it was equilateral? What do you think? It's got to be equiangular. So actually, I can put arrows on both ends. Do you see that? Let's see. They call that, you don't have to know this, I don't care if you know this or not, but they call it a biconditional statement, all right, which means if this is equal to this, all right, then this is the same as, I shouldn't say equal. If this goes to this, then this one goes to this one, all right? So that's why the arrow's in both directions. So I could write two statements. I could say, if it's equiangular, then it's what? Equilateral. I could make another statement that says, if it's equilateral, then it's equiangular, okay? That's why we just, instead of writing all that, just put these arrows on the both ends like that, and that's exactly what it means. We okay with that? All right. So that should be enough information to do what we are going to do in this lesson. So what did I give you? 1 to 12, 18 and 19. So you're doing 1 to 12, and you're just doing 18 and 19. This is section 4.4. This is just in case you don't have the lesson plan thing I gave you earlier. And it's page 172, 173. So pages 172 and 173. There is your homework. Okay, that is due tomorrow.